Welcome to Section 1 of the Contact Manager, Part 2, Searching and Sorting. In today's lesson, we'll begin by getting our Contact Manager project caught up with the code from previous sections, so you have complete working code before you get started. And then we'll proceed to look at the linear search algorithm. The easiest way to get your code caught up is to download the Eclipse project, Part 2, Section 1. For those of you who don't use Eclipse or feel like the code that you've written in previous sections is caught up and is functional and you want to keep using that code, all you need to do is you need to add the contactlib.jar file to your project. Make sure you add it to the build path, because we'll be using it in today's lesson. For those of us that are importing the project to get started, now if you have a previous version of the project that you want to save because it has references to code in it that you liked or you want to be able to go back and look at, you should rename that project. I suggest that you tack on your last name and first name at the end of the project. You can't have two projects with the same name, so it's important that this project have a different name if you're now going to import the current Contact Manager project, which you do by going to File, Import, choose Existing Projects into Workspace, then click Select Archive File, click Browse, navigate to your Downloads directory or wherever you saved the file, find Contact Manager Project 2-1, go ahead and click Open and Finish. And that will get us ready to work. I'll use the disclosure arrow to view the contents of this file. You'll notice there's a new library in there called ContactLib. If you look in referenced libraries, you'll see it there as well. Let's open the source folder and the default package. And you'll notice that if you look at the contact class, you can also use this as a reference to check your own answers against this class, because it has all of the methods filled in with each step and how I chose to complete that step. Now please keep in mind that this by no means represents the only way to solve each of these individual tasks here. It is simply the step-by-step method that I chose to follow. Yours may vary. Okay, so now that we've got the code, we're ready to start. What we're going to do today is we're going to learn about the simplest search algorithm, the linear search algorithm. So we're going to create a new class, which we're going to call our search runner. Now we'll be using the same runner here for both the binary search, which will be part of the next lesson, and the linear search, which is part of this lesson. So we're just calling it search runner since we're going to put them both in there. Okay, so what is this class going to do for us? Well, this class will create a list of contacts and then proceed to search for contacts that have matching criteria using first a linear search algorithm and then a binary search algorithm. Okay. Then we'll discuss the advantages and limitations of each search algorithm. Okay. It should be pointed out that this class uses the ContactLib library to quickly generate large lists of contacts in alphabetical, ascending or descending or unsorted random order. And you'll see what that means in just a moment, because that'll be our very first task. So I'm going to put my name on this. And let's put the version in there, which we will do using today's date, 2015. And then we're ready to begin. Okay, so before we can start learning how to do a linear search, we need to have some data to search. And we could sit here and we could populate our, make it an array list, and we would do that by saying list of contact. And then let's call our list people equals new, and then we can make an array list of contact like that. And that would certainly be the way that we would typically start. But we want to have a list of 20 plus contacts. And if we do this, we're going to have to sit here and we're going to have to manually enter contacts. So instead, we're going to cheat. We're going to use the contact lib to make contacts. And look at this. It even has the ability to make a list of contacts in a pre-selected order. Well, what do we know about this order of contacts variable? What kind of information does it want? Well, if you hover over make contacts, it should call up the Java doc. Let's go ahead and delete that and do that again. And let's see if we can get our, whoop, why aren't we getting our Java doc comments? Well, let's do it this way then. So here we have what's called a variable that is in the form of a constant that is included in the class. So what does that mean? Well, we could see by typing contact lib dot, and then notice there's these what we call constants here. Order ascending, order descending, and order unsorted. Well, we want a list of contacts in ascending order, so we're going to choose order ascending, and then we can tell it how many contacts we want. We're going to go with 20 contacts, and then the only thing that we have to add to complete our code here is we need to import our java.util.list. Get our imports in order. There we go. Now, what we want to do next here is we want to see this list of people that we just created. But we're going to want to do this possibly more than once throughout the course of this lesson. So let's create a little utility method to make this easy. So what we're going to do is we're going to create a static method, static void, and we're going to call this print contacts. Let's do it that way. Okay, and then this is going to take a string that's going to be a title, and then a list of contact, which we'll call contacts. Okay, what are we going to do in this method? Well, we're simply going to go through and print out each contact with a title above it all. So we're going to print the title first. Then just below that, we're just going to do a simple for loop. So I is less than. Now we want to go through all of our contacts, so we're going to use the size method to find out how many we have. Okay, and then we're going to now do a print where we're going to print out first a square bracket, then we're going to print the index, then we're going to print another square bracket, and we're going to put a tab so all our names end up lined up, and then we're going to print contacts dot get I dot get last name first, because we want our contacts to be printed in last name first order. Okay, and then we're going to call this little method by saying print contacts. Let's see, what do we want to do here? We want to say, well, these are our contacts. Okay, and what are we going to pass it? We're going to pass it our people list. Okay, so now we're going to, let's see, run this code and see what we get. Whoops, we got the wrong code window because I didn't have that open. There we go. So if you get that in Eclipse, you get apparently the wrong code. Click in the runner, the method, the window that has the main method in it that you want to actually run, and then click run, and you'll be sure to get the correct one. So notice we got here a list of contacts, and more importantly, notice they're in alphabetical order. So we can change that order very easily by changing this constant here that we're passing to our method. So let's make it order descending and see what we get. Well, predictably, we got the order in the other order, rather descending from last to first. Okay, and then now let's check out our last order, and it's important to understand that this is order unsorted. It's not exactly random because notice the last name here. We got Park Jennifer and Toyuka Alex. Notice we get the same order each time. However, it's unsorted. The names are not in alphabetical order at all. So they're not random, they're what we call unsorted, and that's because we want to be able to have reproducible tests. So we want them in the same order each time, which is what this does. Okay, so now we've got our data. Let's go ahead and put it back into order ascending. And now what we want to do is we want to write a method to actually search for a name in our list. And typically when you're doing this, your method will return the index of the matching element in the list. So what we're going to do here is we're going to say public static void, int linear search, and then we're going to have a string that we're going to try and find, and we're going to have a list of contact, which we'll again just call contacts because it's a list of multiple contacts. Alright, so what are we going to do? Well, first we're going to set up a variable that's going to eventually hold our matching index. But it's possible that that index won't be in the list. So we're going to have it start off as -1, and we're going to write the last line of our method first by saying we're going to return matching index. Okay? Alright, in between, we're going to keep track of one other element that you wouldn't normally have as part of a search algorithm, and that is we want to keep track of its efficiency so we can compare the binary search to the linear search. So we're going to create a variable that we're going to call iterations that's going to keep track of how many times this method loops to perform its search. Alright, what is a linear search? A linear search is simply going through each element in the list, starting either with the first or last element. And if you started with the first, going to the last. If you started with the last, you go to the first, in order, skipping no elements. So we're going to do a simple forward search here. So we're going to say int I equals 0. I is less than contacts dot size again, I plus plus. Okay, then we want to keep track of how many iterations we have in our loop here, so we're going to do that. And then we're going to say, okay, contact a person equals, and then how do we get something from the list? Well, the name of our list is contacts, and then we use the get method, and we want to get the person at index I. Okay, so we now have that contact. We want to get their name in last name first format, so we're going to do string last first equals a person dot, and now we can do get last name first to pull out their name in last name first format. Okay, and then we're just simply going to compare to see if that equals the name that we were looking for. So we're going to say if last first dot equals find name. Well, in that case, we have found the correct match. So we're going to say matching index equals I. And in order to make this loop end, we're going to use a little sneaky trick. So there's two ways to do this. The way that is outside of the AP subset that most programmers would do would be to put in a break here. The other way to do it, the sort of cheating way, is to simply say I equals contacts.size, because then when the loop repeats, it will simply end. Okay, there we go. So now we've actually completed our search algorithm. When we get here, we need to see the results. And there's two possible results. Matching index could be -1, in which case there was no match, or it might be that there was actually a match found. Now, also normally in a linear search algorithm, you would not print anything to the console. But the goal of this method is actually to learn about the search algorithm. So we're going to go ahead and do some inappropriate system output here. We're going to go ahead and start by doing a system out print line that says this is a linear search for, and then the name that we're searching for, and then let's see. Let's see, that will take care of that. Okay, and then we're going to say if matching index equals -1. Well, that means that the search failed. Matching index. Oh, I didn't get. No, not sure what I got wrong there. Oh, equals. My bad. Okay, there we go. This means that we didn't find a match, so in that case, we're going to say system out print line for found no match. Okay, and then if matching index is not -1, then that means we did find a match. So in that case, we're going to do a print line. We're going to say what do we want to say? We want to say found. What do we want to say? We want to say found contacts, and then we want to go ahead and print the contact. So we're going to say contacts dot get matching index plus, and then we're going to have to go to a new line because remember a contact is going to be 3 lines long, and then we're going to say at index plus matching index. That one's quite a long line there. Okay, and then finally we're also going to print out, regardless of the results, we're going to print out that the search took blank iterations. Okay? Alrighty, well, we've now written some code. It'll go through the entire list looking for an exact match. If it finds the match, it'll print it out and tell us where it is. If it doesn't find the match, it'll tell us that there was no match. Now, normally, we would be able to say here, we would actually store the result. But in this case, we're just going to do a linear search. Oh no, we're going to set up a variable first. Let's say string. What do we want to say? Search equals, and then we're going to have a name that we're going to search. So I happen to know that Bowden, Carson is in the list, so we're going to search for that. And then we're going to say linear search, and we're going to search for our search string, and we're going to search within our people array. Okay. So let's see how we did here. We're going to restore our console window and run our search. And here we go. So, linear search for Bowden Carson, found Carson Bowden, 604 Marshall Road, San Diego, 50737. Notice that all of this data is garbage. These are purely made up values at index 2, and the search took only 3 iterations. Well, that seems pretty good. Well, what would happen if we searched for a name that wasn't on the list, or if we simply spelled his name wrong? Let's make it a lowercase c and find out what happens. Well, we found no match, and the search took 20 iterations. So our results went from something really low, a fast search, to a very slow search. And you can imagine if you had millions of contacts in there, that could take quite a while. Also, you might ask, well, why did it go so fast the first time? Well, it's simple. The answer is that Carson happened to be the third contact down in the list at index 2, and therefore the search stopped when it got to him, and therefore it completed relatively quickly. So let's try also going with somebody who's further down on the list. So we'll paste that name in there so that we know we got it right. Run our search, and once again, the search took 20 iterations. So summarizing the linear search, we can say a few things. It is very, very simple to write. You simply iterate through the list until you find a match. It's not very efficient. As the size of the list grows, the number of iterations it takes to find your match grows at a 1-to-1 rate. Thus, it is a linear search in that it proceeds linearly along all the elements, but it is also a linear search in the sense that the amount of time it takes to find a contact increases directly with the number of contacts that you are trying to search. And that is one of the limitations of the linear search. If you could imagine Google performing a linear search for something you were looking for, you'd be waiting quite a long time to get your search results back. So the question is, are there better ways to perform searches? And the answer, of course, is yes, but they, of course, come with their own limitations and disadvantages. All of those are things that we will learn about in the very next lesson. That is, of course, the binary search.